Hello, everyone. Thank you for joining me today. And my name is Spurti Rai. I work as an associate data scientist at AiSPRY. So, I am here to talk about a really important project focused on wind turbine failure and how we can use data and technology to solve this problem. So, wind turbines are a good way to generate clean, green energy, but when they fail unexpectedly, it can cause big problems for power generation and cost a lot of money to fix. Today, I'll walk you through the contents. So, first, let us discuss about the client. The client is one of the leading green power generation companies. That means they are a company that focuses on creating electricity in an eco friendly way using things like wind turbines. Wind turbines are those big, tall structures with blades that spin in the wind to generate power. Our client relies on these turbines to produce electricity, so keeping them running smoothly is super important. Now let us understand the business problem. The statement goes like this: unplanned failure of wind turbine engines is leading to huge losses and negatively impacting electricity generation. Unplanned failure of wind turbine. So, what does that mean? When a wind turbine fails unexpectedly, that means it breaks down without any warning. It is called an unplanned failure. This is a big problem for two reasons. First, when the turbine stops working, the company can't generate electricity, which means they are not producing the power they promised to deliver. Second, fixing these turbines is expensive. They are huge machines, often in remote locations. So, sending a team to repair them costs a lot of money and takes a lot of time as well. So, these unplanned failures are causing the company to lose money and struggle to meet their electricity generation goals. So, now let us see what is our objective is. How do we tackle this? Minimize unplanned failures. So, in simple terms, we want to stop these unexpected breakdowns from happening as much as possible. Instead of waiting for a turbine to break down and then fixing it, we want to predict when a turbine might fail ahead of time. Okay? That way, the company can fix the turbine before it actually breaks or keep a backup ready during a planned maintenance session. This would save them from losing electricity production and spending extra money on emergency repairs. It's like knowing your car might break down soon, so you take it to the mechanic before it leaves you stranded on the road. Okay, so now let us see what is the business constraint we have. Next, we have something called maximize power generation. This means that while we are trying to prevent failures, we also need to make sure the turbines are running as much as possible to generate electricity. We can't just shut down the turbines all the time for maintenance because that would mean less power being produced. So we need to find a balance. We want to fix potential problems, but we also want to keep the turbines spinning and generating power for the company. This constraint makes our job a little trickier, but it's an important thing to keep in mind as we work on this project. Let us also discuss about the second part, that is the success criteria. Coming to the business success criteria, reduce the unplanned failure of wind turbine engines by at least 30%. This means we want to cut down the number of unexpected breakdowns by 30%. For example, if the company currently has 100 unplanned failures in a year, we want to bring that number down to 70 or fewer by predicting when a turbine might fail. We can fix it before it breaks, which will help us reach this goal. This is big win for the company because fewer failures mean more consistent electricity production and less money spent on emergency repairs. Coming to the machine learning success criteria, that is, achieve accuracy at least 85%. This means that uh, It's about the technology we'll use to predict failures, which involves something called machine learning, or in short, we will say it as a ML. Okay, I hope everyone knows that machine learning is like teaching a computer to look at data, make smarter guesses. Okay, in this case, we'll use it to guess whether a turbine is going to fail or not. Okay, the accuracy here basically means how often the computer's guess is correct. Okay, we want our machine learning system to be right at least 85% of the time. So if we use it to check 100 turbines, it should correctly predict whether a failure will happen or not for at least 85 of them. This is important because if our predictions aren't accurate, the company might end up fixing turbines that don't need fixing or missing ones that are about to break. Coming to the economic success criteria, that says achieve a cost saving of at least $2 million per year due to the reduction of unplanned downtime. Fine. In this criteria is about saving money majorly. Unplanned downtime is the time a turbine is not working because it broke down unexpectedly. By predicting failures and fixing turbines before they break, we can reduce this downtime. So, we want to save the company at least $2 million per year. $2 million per year by doing this. So if they are currently spending a lot on emergency repairs and lost electricity production, our solution should help them save at least $2 million annually. That's a huge amount of money, and it shows how valuable this project can be for the company. Now let us understand about the data. Let us see the data description. Okay, when it comes to a data description, basically this table tells us about the information we'll collect from the wind turbines to help us predict failures. Think of this data like a report card for the turbine. It gives us clues about how healthy the turbine is. The first column would be the date. This is the timestamp of when the data was recorded. It's like a calendar entry that tells us exactly when we checked the turbine. This helps us to keep track of changes over time. The second is wind speed. Basically, this measures how fast the wind is blowing at the turbine in meters per second. Wind speed is important because it affects how hard the turbine is working. If the wind is too strong or too weak, it might stress the turbine in different ways. Third column is power. Okay. This is the amount of electricity the turbine is generating, measured in kilowatts. The fourth column is generator bearing temperature. This measures the temperature of the generator bearing in degrees Celsius. Gear oil temperature. This is the gear oil temperature. This is the temperature of the oil in the gearbox. Also in also in degree Celsius. Okay, rotor speed. This measures how fast the blades of the turbine are spinning. Okay, so we will measure it in the rotations per minute. Okay, and then nacelle temperature. This is the nacelle is the box at the top of the turbine that holds the generator and gearbox. This measures the temperature inside the nacelle. It in basically degrees. Okay. Then comes your bearing temperature. This is the temperature of the main shaft bearing in degrees Celsius. Okay. Then speed. Generator speed. Basically, this measures how fast the generator is spinning in rotations per minute. In rotations per minute. Then your angle. This is the angle between the turbine and the wind direction in degrees. Then wind direction. This tells us which way the wind is blowing. It is also measured in the degrees. Okay, wheel hub temperature. This measures the temperature at the rotor hub. Okay, where the blades are attached basically. So it is also measured in degrees Celsius. Gearbox inlet temperature. This is the temperature of the oil as it enters the gearbox in degrees Celsius. Then the failure status. This is most important column as it is our output label. It tells us whether the turbine failed or not. Okay. Basically, zero means there's no failure of the turbine. One means there was a failure of the turbine. Okay. So this is what we are trying to predict basically. Okay. So we'll use this data, wind speed, temperatures, speeds, to figure out patterns that might tell us when a turbine is about to fail. For example, if we notice that every time the generator bearing temperature goes above a certain level, the turbine fails soon after. We can use that pattern to make predictions. Let me take you to the architecture. Basically, in this case, the first thing what we will do is we will try to understand the business and the data. That is the first case. Okay. Once we understand the business and data, we will see something called as project charter. So project charter and crystal mildew is a document which we will fill, which keeps the track of the entire project, which is a very important phase when it comes to your project, a documentation of the entire process. Then comes the data collection phase. Okay. When it comes to a data collection phase, we have to collect the data of the wind turbine from our client. Okay. So this is something which we already spoke about. Okay. Then comes your storing of the data. When we speak about storing of the data, we will majorly go with our S3 bucket. Okay. To store this huge amount of data. Once you store it, you retrieve it from the S3 bucket and you try to clean the data. Now, cleaning is a very important phase because we have to feed this data to our model. Okay, we will do the feature selection and then further, once the data is cleaned, then we will split our data into train and test. Once we split our data into train and test, we will also save this clean data in our S3 bucket or any other database. So once we save this, then we will go for model building. When it comes to model building, we will try with the different classification models, whether it could be logistic, KNN, different models. Okay. Once we try with different models from basic to the complicated one, decision tree, random forest. So once we try with these models, we will try to evaluate the model as well. That is how the accuracy is. Okay. Once we evaluate the model, we will deploy the model. Once we deploy the model with the help of Streamlit, okay, the user can easily able to get the new data and see whether the machine will fail or not. This is the overall process of the project. Now, what we offer? Challenging real-time projects that push you to your limits. Learning of all phases of project methodology. Learning about different tools used in the industry like Python, Power BI, platforms, etc. Work on research paper that are published in international journals. So you will get access to mind map, ML architecture assistant, resume optimization hub, and animated learning. So that's